Okay, let's start. Hi, everyone. Thanks for coming today. This webinar is going to be about clean tests or dirty tests and how to clean them. I won't be joining with the dog, but hope to do what he's doing. What we're going to talk about today is a bit about clean code, what it is, and how it relates to automated tests, and what kind of ideas we can take from that to when we write our automated tests. And I'll talk about all kinds of automated tests, like unit tests and maybe API tests. The concepts are going to be basically the same. For those who don't know me, my name is Gil, consultant and a trainer for all things regarding making software better. That includes development and testing and product management and agile stuff and process. I'm the author of 2 books, Everyday Unit Testing and Everyday Sprint Testing. And you can find out more about the stuff I do at testingguild.com, or run around chasing me on social networks. That works also. I want to mention that everything that I'm going to talk about today has a very bigger version in both my clean code workshop, which I do in all kinds of languages. Well, English and Hebrew, but other than that, Python, Java, whatever. I've done once in PHP even, and whole day talking about and exercises in a clean test workshop, how to improve our tests. Okay, so let's start. So people ask me, Gil, do you write clean test? And the answer is, yeah, I really try. We kind of think about code differently when it comes to test, and there are a couple of reasons about this. And I'm going to mention those, but it is something that you have to put into your mind and invest in, because the way we write any code is that we write code to make it run, to make it work, not to make it readable, maintainable, and so on. We can't really do both things at the same time. So it does require some kind of effort in order to do that. And even if you look at something that you've written like 2 days ago, or obviously if you've done some kind of code review before, looking at somebody else's code that you haven't written, and that means that you look something like that. And that also applies obviously to our code, because when we write some kind of code, we have some kind of knowledge, some skill, some understanding of the problem. We put that into the code. 2 days later, we're much more smarter. We know a lot more about the problem, and we look at the test, and this is how you test it. Doesn't make sense. So yeah, our understanding of what clean is, or basically how the code looks like, what it tells us, changes over time, because we change over time, which is okay. However, although we usually write the same language, not always, but we don't apply the same standards to test code and production code. Like I said, whenever we're building something, doesn't matter which one, we want to make it work. And production code is kind of we have some kind of an image of how it looks like. Maybe hopefully we've done a couple of design phases, and we know where we're going. Testing is not the same thing. We kind of know what we want, but we don't invest too much in design. Sometimes we use tools that generate these kind of things, and this is not going to tell you a secret. These tools are not great in making great code. Yes, they are creating what you need, but probably not what you need for all the time. So we look at this kind of code differently. And there are reasons for that. First of all, we don't consider production code and test code as equal, because production code goes into production, test code doesn't, and therefore it is, in our mind, equals a bit less. There's another thing that although we know we're going to go into the code in the future, could be like tomorrow, could be like 3 months from now, it could be a year from now, but we know that if we invest in something that we're going to go into, again, that makes sense. Tests are not like that. Tests are like once they pass, we don't look at that anymore. So we can, it's working. Yeah, let's move on to the next one. And the investment part I was talking about, like going back and making it better, readable. We usually don't do that. So we don't go back to that. So we don't apply the same standards, and we don't build it the same. When we kind of build production code, like I said, when we do a design, we kind of draw cubes on the board and do that. With tests, once we have like a passing test, we're gonna copy and paste it and mutate it a bit because it's working for case number 1. Case number 2 is pretty close with that. So we're going to copy that. And we create a lot of noise and smells, which I'm going to talk about, by copying that, a lot of the application that we don't like. In the end, there is something that we need to keep in mind, and that is that what we are paid for, what our job is in the software industry, is code that works over and over again. So code that works, if it works for once, great. We don't touch it again, excellent, write it any way you want. But the idea is that we're going to get back into this code again. And we need to convince ourselves, this is not easy, that we are going to do this also for tests. We're going to read the tests because tests are going to fail. We're going to look at the code and we try to understand, what is this test testing? What is the setup? Why is that test passing and is brother or sister test failing? We need to see that, because in the end, this is what we want, but it will get faster to that point. So the clearer the code, it will be easier. So we need to think about it like this. That's our real code, and a test is a real code, and we need to apply the same standards. Of course, if you're not applying any standards to your code, you're practically there, but this is not where we want to be. So let's talk about clean code. And like I said, we can talk about a lot about clean code and patterns and what it means, but there are a couple of things I want to talk about because we're going to grab a couple of ideas from there and apply them to the tests. I think the most important thing about clean code is that when you're thinking about time, not about time travel, unfortunately, but unless you're writing code for a time machine. The idea is that we're investing something right now in order to grab the benefits later. And most of the stuff that we do around quality is like that. We don't want to fix bugs. When we do that, we want to do that as quickly and as safely as possible. So basically, we're investing now in tests, in reviews, in whatever you're doing in order to create better processes to save time for either your friends, your colleagues, or your future selves. And like I said, what we like to do is like build stuff that works. And in order to do that, we don't like to do the other stuff, which is the documentation, maybe even testing, whatever, I don't know, whatever you like and don't like. But the less we spend time in things we don't like, that means that we'll have more time for the things we do like. And this is like clean code when you're actually keeping your code readable, maintainable, testable, all these able things, which are really hard to measure. Then you basically spend more time in the future based on this investment right now, which is not that big, to work on the other stuff that you do like. And I think that's worth our time. Usually when we talk about code reviews, like clean code is something that you write, but in order to ascertain whether it's clean or not, you need another set of eyes. It could be our eyes like a couple of days later. We're probably going to be very critical about what we did. But if we want to criticality now, we'll get other people to look at our code. And this is like, without any supporting process like a code review, it will be hard to create something that other people can use. Like I can read it because I wrote it. Makes sense, but can other people read it? Yes. Will it take them time to understand and fix and do something with it? Probably more if they don't understand what it does. So I went and picked up a couple of what people, like great people, think about clean code. And the first one is Grady Butch. Grady Butch is one of the three people who created the object orientation movement in the 80s and 90s. He created the rational program. He said clean code is simple and direct. It should be written like prose. Like think about a book or song that you've written, wrote, read. And look at the code that you write. It doesn't matter, production code or test. Does it look like a book? Does it tell a story? Do you understand the story from that? Usually not. Usually not. Yeah. So it can work like that because it's like we decide of how the code looks like, but it requires some kind of effort. Michael Feathers, who wrote, I think, the Bible on unit testing, it's called Working Effectively with Legacy Code. He said clean code always looks like it was written by someone who cares. Now, why would someone care? I think it goes back to the time thing. We save time, we respect the time of other people, and we do that because we care, even if it's going to be us. We care about us as well. But whatever you do, whatever you're going to care about, this investment is something that you need to say, well, this is going to help me in the future and help me or other people. Martin Fowler, he's one of the people who created the Agile Manifesto, written a lot of books, and City of ThoughtWorks. He said any fool can write code that the computer can understand. Good programmers write code that humans can understand. And that's true because you can write code that works in zeros and ones, and the computer will finally understand it. It will take you time, but you will get there. But the only way to pass this code to other people and they will make sense of that is that they can actually understand that. And that means that we write like prose, the way other people, the way the audience is how they are going to read it. So we want to take these things that are the ideas that, well, this is how things that principles that make code better, maybe patterns, and we talk about those in a minute, and take them to tests. And I'm going to discuss a couple of things that kind of make up clean tests. It's not all of them. It's not a definition. But when you look at these kind of automated tests, you say, well, it's not like I'm going to have fun spending my time in there, but it's not going to be a miserable time. And the first one is that they show intent. Tests are an example of using the code. If they're unit tests, they're an example of a small function. I'm passing inputs into these functions and see what it returns. If we're looking at an API or maybe a workflow in the software, like a longer test and end-to-end tests, we want to look at the test and say, I understand what it is doing, what it is manipulating, what I expect to see back. If it doesn't, or it makes it hard for me to understand, the intent is lost. Now, a lot of the time we write tests, whatever, 99.9% of the time, we write tests using frameworks, libraries, whatever, because if we wrote everything from scratch, it would take like all time. So what happens is that you have like a couple of languages in the code. It has like the logic language, and it has the framework language. It has this library language, because all these kind of languages, the frameworks are general purpose. They are meant to fit everyone. So it's not like they're using you can use that in your financial application or your medical application, but it doesn't have any terms of medical or financial stuff. It has open handle, which doesn't mean anything. So these kind of things create confusion, or not like super confusion, but it will take us more time to understand what it's doing. With more time comes a bit of confusion, but the confusion creates a bit of bugs. We don't want that. So we want to see that in the test, what it is doing, how it's going to use the code, and what is expected when we want to see that. It's focused, and you can see that a lot more in unit tests, obviously, but the bigger the path of the code that we're testing, it's going too hard to name this, the name of the test, because it's doing a lot of things. But the more we know what it's doing, the more the test is focused, we can understand more, because we do kind of a mapping. Well, this does this, and this one relates to this part of the code, this bit relates to this part of the code. We're not doing this for fun. We're doing this to fix bugs and know where to add stuff, right? So it will take less time than that. If you know about a single responsibility principle, it's an idea that comes from clean code in object orientation, let's call it. Probably the shortest thing to say about it is, if you have a class, it has to do with something, one thing. If it's doing a couple of things, it probably can be broken into two things, which will own its own responsibility. And the bigger the test, meaning it tests a lot of code, it will be hard to say where the problem is. It will be hard to debug it. And everything we associate with smaller pieces of code, even understanding that, goes back there. So the focus to test, and probably that means that we may want to break bigger tests to smaller ones. It will help us with understanding them. This is something that I fell into this trap a lot of times. I create tests, and then test name. Okay, I say, well, this is what I'm going to test, and I'm going to. This is what I'm going to check, and I write this test, and on the way I say, I'll probably need to do something else, and I'll remember that, and I'll go back to the name and change it, and I forget. So test names are not checked by the computer, the compiler, whatever you're using. The only way you can check it is by in your eyes, or somebody who reviews that code. So that whatever you do, you need to have a match between the name and what it does, because if you don't, what will happen is that, imagine that there's a bug in there. The first thing that you'll see is the test report with the name, not the code, not the test code. So it will give you an idea of what's wrong, but it will give you the wrong idea. Now, that's obviously bad. Is it like dramatically bad? Depending. You probably figure things out when you start debugging and stuff. But yeah, you save time if you actually make sure that the code and the test and the names go together. The final thing is the language thing, the abstraction. If we want our code to look like it tells a story, it's to tell it in one language, not in multiple languages. So any implementation details like our handles, we might want to abstract it. And I'll give you an example, sure. There's such a thing called code smells, which are basically anti-patterns. The idea of the code smell is that if there's a problem in the code, and it's not a functional problem because the code actually does what it needs to do, but it will cost us in terms of maintainability. And the same things we're going to apply to test smells. I'm going to mention a couple of patterns or anti-patterns in code, and then after the demonstration, I'm going to talk about, well, how did this apply to test code as well. So these are like a very, very, very short list of test smells or code smells, sorry. The first one is like big classes, they're called God classes or God methods. There's usually a question of how big should a method be, and it used to be like it should fit in a screen, but then screens became bigger and resolution became higher, and definition no longer works. So, but we know that the bigger the code, doesn't matter which language you use, and even if we're talking about classes and stuff like that, it will be hard to understand. It will be hard to find what we need to change. Same goes for methods as well, like functions that are like longer. If we're talking about classes, and we'll talk about test classes, usually that's a big thing because if you think about test classes, it's very easy to add like another test in there, right? Is that its place? Not really sure. You need to think about them. So that's a smell. You look at this code, you say like it's big, and you understand that it's going to cost us when we go in there again. Another thing, code smell is something called comments in the code. And the reason we usually talk about this in anti-pattern is that usually if I write a comment, that means that the code is not expressive enough. It doesn't explain what it is doing. And the main problem with that is that sometimes we change the code, but we forget to change the comments. And again, like names, nobody checks that unless we're doing a review. So we'll see how comments apply in tests as well. Uncommunicative names, like I said, the first thing that you see in your test report is that this thing has failed. If you have something like called test 13 has failed, it's not useful. And that means that, again, is that a disaster? No, you'll go into the test code and see what it's doing, and it will take you a bit more time. But if it told you what is happening and you can compare it to another thing that is passing, you can actually like do the math in your head and say, the problem is there. It will save you time. The final thing is, and this is, it may be called constant literals, depending on which language and which technology you're actually using. But if you see something in your test, and we see that a lot in tests, that like user ID is 17. Why 17? Could it be is 17 special? Like, can I use 18 instead and the test will still work? Or maybe 17 is something that is more important. So the more we use explanation in our code, like enums and stuff like that, we can convey more information. Tests become more expressive, and people will get them and will use them more effectively. Okay, so let's look at a couple of examples. So I'm going to show you this in Java, but like I said, it applies, principles apply to any language, some more easily, some less easily. A lot of the time what we're doing in order to get to cleaner code from code like this will be to refactor it. And refactoring may be easy or hard depending on the tools that you have. In Java, you have a lot more options to refactor automatically, like in IntelliJ, than you do in JavaScript, for example. So that means that if you're really keen on actually refactoring, you'll use the tool a lot more, and you do more refactoring. And in JavaScript, you kind of be reluctant to do this because you'll probably do some renaming and stuff, but maybe not beyond that, because again, every manual change that we do, especially in tests, which we don't have tests for, we won't have the feedback to know that we broke something. Okay, so what do we have here? So our application today is a very stupid calculator, and the code itself, it doesn't really matter, but you can see that if you know Java. If you don't, I'll explain. This is an API with a post. The consts in the code tell you the routes of the API. This is the root, and this is a /calculate is where the API is. This is the code of the controller. It gets a body in a form of an object called calculator params, which has a first, second, and operation. Like we imagine sending a JSON with a first, second, and op. It will eat that, and based on the operation, we'll do the calculation. It doesn't really matter because this code, we're not going to see it again because it's not very important. What we're going to look at is test code. Okay, so where do we start from? Like, we have like 3 tests here. So when I wrote it, it was actually like written it like that. Some of it is on purpose, I agree, but you'll see you see that there is already things here that we talked about. First of all, is the copy and paste thing. Like the first one is test add, a very good name. It has a comment, and the second one is something that we do a lot. Then we do something, and then we mutate it a bit, so we copy that. This does the same thing with negative numbers, and we need to give it a better name. So maybe it's the same name, but with the twist on it. So just add minus maybe. And when we copy, sometimes we copy the comments as well, which is fun. You can see in each of these, basically what we're doing is building the calculator programs, loading the numbers in the operation. This is creating the body of the JSON from the calculator programs. This is creating the request and sending it to our server and getting the response. And basically, this is a plain text response. So I'm not even doing something with JSON and just asserting that the result is something. And this pattern obviously returns because I copied it, because it's easier to copy something that works and change these things here and this, and voila, I have a working test and a next one. So this is how we usually do this, but let's see what we can do in order to improve that. So this is our beginning 3 tests, not very good, a lot of duplication, and we'll take it step by step. So the first step is to remove the duplication, obviously, but I'm going to use do this in a couple of steps. The first one will be to use, I'm using a JUnit here, and any framework probably has something has before each or before all. So when you're doing that, it will look like this. So what happens is that you have a before each method, which is called before every test, and every initialization, we move it here. So you can see already that the test inside like squished. Very good. We like smaller things, but we did another thing in this version, the original version. Each one has the type here. In JavaScript, it will be like a const or TypeScript. You have something here that I'm not sure it's helpful. It's probably noise, because if you use good names like headers and stuff like that, or mapper, you probably not need the type there or the const. So by pulling things into a setup method, you can get the local fields, local variables, and put them up into fields, and the declarations are there. And now your tests are not only smaller in terms of size, they don't contain the noise of the declaration. Because again, things that repeat are noise for us. We usually want to look at things that are different. If it's something is common, either something will happen in the setup, and then all the tests will fail, and it will tell us, the problem is the setup, or everything's great and everything's common, still working, and this test failed because it's different than this one. We want to see the difference in our eyes. So that's the first thing to do, and each framework has something like this. Usually, you can do something similar even in non-object-oriented languages. Okay, so that's cool. Let's look at names. So obviously, setup is great because I gave it right now, but we know that the test names like test add and test add minus and test minus are not really good. There's also this comment that I copied here, which look at the comment, check that we can add 2 numbers and return the right result as a string. Yeah, it exactly tells us what it does, but what is the right result? So comment doesn't really help here. And like I said, do the names differentiate between the tests? So let's do something about that. So I removed the comment and called the first one, add 2 numbers and calculate result. If you're working with JUnit or JavaScript, C#, whatever, a lot of the time you don't need the prefix test in it. You already have this. Like you're looking at a test report and everything begins with test. That's noise. Some things like in Python test frameworks like unit test, you need to use test because the framework tells you so. But think about if you need it, and if it's like noise, remove it. So this one, add two numbers and calculate result, add two negative numbers and calculate result, subtract two numbers and calculate result. Now, you already see there is some kind of application here also, and calculate result. Now, a lot of the time with algorithms, you'll find that you throw numbers, like in our case, and all you want is the correct result. Yes, you can call it this test checks -5, -4, and gives you -9, but again, you look at the code, at the test, like in the test report, how is that different than other things? It doesn't tell you what this example of using is really doing. And this gives you a better one. Add two negative numbers. And if you can see like, and calculate result like repeating itself, maybe remove that as well. That's a possibility to do. Again, that's noise as well. But it's okay. It's up to you to decide this. Nobody will tell you otherwise unless they're reviewing your tests. Okay, so we've done this. Let's talk about mode application because as you can see still these things repeat themselves. The only things that are different basically are the first, second, and ops. Sending the request is the same, and then there's the assert. So common functionality. So what we can do is extract a method. So that's what I did. So you can see what I left in the test is set first, second, and ops. That's the setup things. And then created a call calculate method in the class. Right at the bottom here, pulled everything that is sending the request. Now, look at it. Now, you can see that by pulling these things in, I pulled out all the framework code, the JSON stuff and the REST template and the post stuff here. And what's left here basically is something that reads more like application logic, which I like, because what I like my test is to tell me a story. Note that in this case, before we do that, all the requests are going to do the same. So at this point, I kind of send it by a parameter, but what I'm going to do next is like set it as a constant and we don't need to pass it. So let's talk about constants and literals. So the first thing we can do is pull this thing here, like create something called a local URL. And note that I'm using HTTP localhost because it's a local URL and then the path itself. Like I said, I removed the passing this from the parameter and I'm just use this as a constant here. But that's one way to do it. We can go further because remember, I showed you that in my production code, I know I promised not to show it again, but the constants are important. In my production code, the paths are there because if I'm going to change the paths in the application, I don't want my tests to break. So what if I build this kind of thing in the test? So let's do that. So now I'm using the literals from the code. So I have a test local URL, which contains just the localhost part. And in the setup, I create it from the production values. So basically what I did is two things. I created something that says, well, this belongs to the test, while other stuff aren't. And I kind of created a better, more resilient test because it now takes the production values rather than its own. So it won't break just if I change production stuff. And that's nice. And question is, well, should I leave it like this? And the answer is no, I have three more things to show you. Okay, so what else? The first thing that I'm going to show is something called a builder pattern. A builder pattern is using an object to build something for you. In testing, we usually do that for either creating an input object, like create something like a giant JSON for me, or a reference object, when something comes back and I want to compare it to. Again, could be like a JSON or binary or whatever you have, instead of just doing set, because currently what I'm doing is like setting everything in, but and imagine like something big. You don't want, if you're going to first of all build everything from scratch and just want to keep the different things from there, you won't see it. Like it will become very big and you won't see, well, this is the different thing. Remember, what we wanted is have the common stuff somewhere else. So the builder lets us do that, and it lets us do that by having defaults, and it looks like this. So basically a builder object is something like this with an API that you decide. We call it with first, with second, with ops, and it starts with defaults, and it usually has a method called build, which creates the object that you want to build. So this creates the calculator params and sets the object that you collected in and returns it. And the test looks like this. Param builder with first, with second build. Now, you just look at it and said, well, what did I save? Well, first of all, I saved the with plus because the default is plus. But that might be a very big deal because if you look at, remember the second one doing also a plus, the third one doing a -1. And, in order to do that, I need to change that. You might look at this and say, well, it's probably going to be more readable if I put with ops in with plus. And you might be right if these are the only parameters. But if you have like 20 parameters, you probably want to create a default object once and modify it through a builder. And then you create what you have here is the differentiation between the tests. And again, this is what's important for us, because when it fails, we want to know how is this different than the other things. So a builder object is kind of pulling a lot of the initialization to somewhere else. And we did that already with our method here. And we're going to do that a bit more. Now, remember, we talked about this is like platform code and this is the application code. Let's see what we can do. Well, if this is one thing and our tests class doing more than one thing, let's put it into a separate object. So let's call it an API call wrapper. It's not very originally, but it contains all the things that it needs to do. And I created the post with body here. It is more generic because it will take the URL and the body and it will create for us. And then this way, other tests and other test classes can use this, and maybe we'll extend it to have like get or something like that. And it become more useful, not just for our test. But look at what we did also. Because I put it in another class, the HTTP and REST template, these kind of objects are now sitting in here. They are no longer sitting in our test code. So what's left here are only things that are relating to the application logic. And it's much easier to maintain because it has less code, easier to understand, so on. And I would use it like this, basically. I want to show you something else, though, that is relating to naming and constants. And you can see, like, this is very algorithmic phase. So I'm throwing numbers in it, 3, 4, -5, 9. Remember, I told you, like, sometimes you're using a user ID equals 17, and maybe that you don't understand the significance of 17 in the test. But if I asked you, you would say, this is a user that has a permanent discount. So why not call it a discounted user ID or something like that? Yes, we can. And we can do more than that. This is a pattern that I'm using a lot. let's say, and I know this is not a great example, but let's look at it this way. Let's look at the final one, and remember it's doing 20 minus 4. Okay. So sometimes you have like things that need to pass the test. Like you need to fill the title, because if the title will not be, if the title will be empty, then everything will break. But as long as it's not empty and can be anything that you want, uh, it's okay and doesn't impact the tests. Okay, so we can use something with the prefix any, like I did here. And I do that to signify that these are the things that, yes, they make the test pass, but they're not that important. When I put the in front of it, that tells me, or it gives me a signal that this is something that is more concerned with this specific test. So, sorry, using the uh, prefixes like this, or any patterns that tell you this is important and this is not that important, will help the people who read your tests to understand what they need to focus on and why they don't need to understand everything equally. But because usually we don't need everything equally important in the test. Okay, so that's what I wanted to show you in terms of demo. Let's recap what we saw and talk about that. So we talked about big classes. Remember how big it was at the beginning, and basically we just moved code around. We removed some of the duplication, but we kind of, it's like we didn't save too much on code lines, but that's not the point. When we're reading a big bit of code, it has some kind of baggage on our mind. We kind of take a step back, and it will impact our ability to understand it. So smaller stuff are better. Test classes, like our test class today, or any text fixture that you want, they can expand very quickly because it's easy to say, well, just another test going in there. Now, it does impact one thing. It used to be that you probably will have a longer time to find out where to put this test if you like different test classes. Well, obviously, if I have one, just put it in there and everything's fine. But if you're doing iterative work and you're going to run those tests all the time, it will be easier to spread them around, because with the tools that we have and shortcuts that we have, it's easier to run specific tests or just test classes if they're smaller. And if we want to run test and we want just its result, I'd rather to run it alone, if it's possible, if it's easy, or with 3 friends rather than 50 friends, because it will take time. And in sometimes it is observable. In unit tests, it's not that big, but when we're talking API tests and end-to-end tests, it is observable, and you want a quick feedback. So spread the tests around and remove duplication, obviously. Comments, we talked about this. Names are like comments. They don't change if we don't remember to change them, and the tools that we have, our IDs, will not tell us. So write more expressive code. That means that you need less comments, and think about the names as this as well. Especially if you're using something like in JavaScript, you have Jest and Jasmine, we can, or in Spock, in Groovy, you can write like entire sentences instead of with spaces as test names. Again, these are like comments. Nobody reviews them. Nobody tells you this is okay. You might have a spell check here and there, but nobody will tell you this is not testing the important stuff. So review that and compare it to the tests near them. So how is this name? Tell me what's different than this. And if it's not, change that. And we can play a lot with the constants and literals in the code to signal to us what is important, what is not important, what is the meaning behind these numbers or strings. And this is like what we want from my production code and my test code. It's the same thing. I need, these are the same standards that I want from them. I use the tests a bit differently, but you see that the same principles apply, and I can make the code, whatever I'm using it for, more readable and maintainable if I apply this kind of thinking to either production code and test code. And that's how we get to clean tests, the short version. So I want to thank you for coming today. If you have any questions, put them in the question box or the chat. If not, well, you can contact me about the workshops and the courses that I do. Just bother me on Twitter. That's okay as well. On my YouTube channel, you can get more videos like this, or even shorter ones sometimes. So I try to put a new video each week. And whatever you do, think about your tests when you do them. So thank you for coming today. I hope you enjoyed it and it was valuable for you. And we'll see you next time on the next webinar. Bye-bye.